So today we're going to talk about the circle of fifth, the circle of fourth, and primarily string instruments and how that's moved into the electronic music world. So first thing, draw a long line there with a tick at each end of it. Okay, this is the world. This is the universe. Okay. So it's called the electromagnetic spectrum. Electromagnetic spectrum. That implies electricity and it implies magnetism. So in our academic system, we're fairly good at teaching electricity. We don't do a very good job, in my opinion, on magnetism. But it's electromagnetic spectrum, so they go hand in hand. Husband and wife, they all go together. So now about let's say a quarter of the way, draw a tick here. Okay. Okay, now draw another one about the same distance. Okay, another one about the same distance. Okay, we're going to divide that into, put numbers up there, 1, 2, 3, 4. Okay, this is your world. The bottom line down there, number 1, right under there, sound, S-O-U-N-D. Under number 2, write radio. Under number 3, visible, and then others. Okay, now under inside of visible, draw 2 ticks near the other one. Near.
Near which one?
Okay, that's going to be. Okay, and the high spectrum there, that is ultraviolet, so put UV. No, where you just did it, no.
I think under the visible, the right.
There. Okay, on the other side, put IR, infrared. And then where we've got visible, put some lines down, RGB, red, green, blue. Okay, this is the first thing you've got to get as your foundation and then start building on it. We've done a fair amount of talk in the past on some of these. The visible spectrum we've done a fair amount on, the radio we've done a fair amount on, and today we're going to zero in on sound. Sound. Sound is for your ears. Sound is for the atmosphere. Okay? So, sound would go down to hertz, capital H, little z. No, down. Down at the bottom. Down at the start, there, hertz. Okay. Now, I guess I'm trying to think how to transition this over to music. The lowest, okay, draw another line way down. Give some room, there. All the way across. Okay, and put underneath there SPN, scientific pitch notation. So this is music notation as we know it, but it has to do with the physics of music. Okay, way down at this end now, make just a little tick for B0, or A0 and B0. Okay, then we're going to start above the line with C1. Okay, now listen very close. What I want is 8 octaves: C1, C2, C3, C4, C5, C6, C7, Cs.
It's only 7.
And just C1 tick, C2 tick, C3. What we're doing now is dividing music into high, middle, and low. So the lowest the ear can hear is down there at C1. That is 30 hertz. So write down 30, capital H, little z. That's the lowest pedal on my organ. That's the lowest musical note usually. It's not on the pianos, the ones, the A, O, and B. So also, this is called scientific notation, okay? So now, find C4 and circle it. C4 is middle C. Last week I was wrong. I noticed on my videos I kept saying C5, and it's not, C4, okay? Now between C4 and C5, put A, okay, that's A4. A4 equals 440. Okay, now C5 and C6, put an A above the line probably, and that is A equals 880. Now on C3, go below the line again, put an A equals 220. Okay, Haley, show them the slinky. Oh, not that one. Hold that one. Hold it. Okay. We've gone over this before. What is a sine wave? This has to be a sine wave, and it is what we call circular polarized. So it may be right circular or left circular. So that becomes relatively important. You can see it's big. That's the 30 hertz. So if you get a radio license, Elisa, write down the radio license. First license equals 2 meter and 440 hertz. 2 meters, 440 hertz. Okay. So now we're going to go over something we've gone over before and see how much we do remember. Turn the page. Okay, now at the top and on the left side, put XY coordinates. Okay, now the one on your right, upper right, is Roman numeral, no, in the quadrant. 1, Roman numeral 1, left, Roman numeral 2, 3, and 4.
Ivy, yeah.
Okay. Now draw a circle out to the end of that, around all the, a circle around it.
Like that?
Yeah, that's good. We've done this 3 times now. So this is called the circle of units. Okay? So a circle where the mass starts to come in is, put R for radius. Okay, C for circle. No, don't take up that space. Put it down at the bottom. I need that space.
Here?
R for radius. C for circumference. and pi. So now we're switching over a little bit to the math. So radius times 2 times pi equals what? Anybody know?
Circumference?
Circumference. Just look at
Times
2 times the radius. Show them a radius from 0, the x cross to the end. Okay, that's a radius. Now show them a circumference. Right, so if you look at it there, 2 of those radiuses
It's a diameter.
times pi will give you the circumference.
Oh, okay.
C equals 2 pi r. How are you doing? Okay. Now, let's get to the smaller wavelength. Wait, let me just show them. Take this and put that against the X up there, coming out. That is two-dimensional.
What do you want?
Now, when we're talking about our world, it is three-dimensional.
Is that what?
It is
I think
not
so.
two-dimensional. Okay? Good. Give it to me. I'll take this one. And if you want to take that into it, do it again. And I don't know if you can do both of them.
Well, probably not.
So one of these would be 2 meters, and one of them would be 440.
How am I gonna hold it?
So the little one is higher in pitch than the low one, the big one. And it's also got more energy. Music is energy. Okay.
Interesting.
Okay. Okay, now the lines of this circle start another one like we always do over there. Okay. Now, what we're going to do is a little bit of math here, and this is important, and try to get it in your head. So, on that circle, Alicia, go up, that's 0, right where you're at. Nope, over, that's 0 or 1. This is called a unit of 1, okay? So, this is where you need to start hearing it, because you're going to learn more as we get more involved with space and orbital mechanics. Around that circle, put the degrees 15, 30, 45, 60, and 90. Now draw a line up to 15 and one up to all of them, I guess. Okay, now just but drop a line down from the 15 degree. Okay?
Oops.
If you can see what's happening there, okay, show them where an angle is. Put a little arc. No, there.
Well,
That's the angle, 15 degrees up to 90 degrees. Okay, so if you see what you're doing there, now start a sine wave, put a dot on that other line, and go up with it. Stop. Okay, that's quadrant 1. Okay, plus, minus. Now we're going to come down. We're going to go below the line, quadrant 3, back up. Okay, so from the 2 peaks there, put ticks on them. Okay, this is called, if you study this, this makes trigonometry very easy. I had a very hard time with it in high school. But this is what you call visual math. It's where you start learning something with your eyes in addition to your brain. Okay? So this is a sine wave. So the sine is where you got 15 degrees. Put up there on that arc. No, there. On the arc, that's sine. S-I-N. Okay, and then down the line at the bottom, from 0 to 1, put cosine.
Here?
Right, cosine. Cosine, C-O-S-I-N. This is where you start getting all these equations, and back when I was in school, you'd have to have tables. We don't use tables right now. We use mostly calculators. So you have the sine and the cosine. So this is where the equation that's mandatory to learn in 8th grade is down underneath here. A squared equals plus B squared equals C squared. Then right down there, 3, 4, and 5. Okay, this is the equation that you're going to use in navigation, in building, or whatever. 4 is obviously the long one. 3 is the sine that we've got there. C is called the hypothesis. The hypothesis. Draw a triangle down there, a right triangle. Okay. Okay. Now, put your C for hypothesis. Okay. 3 is A, the short one, and 4. Now, probably in the future, as we get into, well, with more math, draw another triangle opposite on the other side. No, over here.
Oh, yeah.
From there.
Well, I don't have space.
Yeah. If you start playing with this, you'll find that it makes some very interesting figures, and you can calculate your equations from there. So you need a circle and a square and that. So let's go back to the top one. The top one there, where she put the two cheeks, is this is sine wave. So put in sine wave. Now, when you're starting to do things with sound and electricity, you want to manipulate this wave. So let's say, go up to the top there, just put a dot up there. No, on the XY axis. The XY axis over, up at the top, up at the top. If you started right at the top there, 0 or 1, it would be a cosine wave. So cosine wave is different than a sine wave. Cosine wave starts up at the top. The sine wave starts on the baseline. So they're out of phase. So that's the first thing you have to start worrying about or manipulating in music is the phase of the sound. Okay. So if you have 2 of them, you'll overlap them. One of them will be 90 degrees out of phase, 40 degrees out of phase, or whatever. So you use that in radio all the time. Okay, so from those 2 tick marks up there, draw a line. Yeah, you got it? From there to there. Draw a line to the other tick line. Draw a line between them. That is called the period. P-E-R-I-O-D. Okay. Hopefully you can start visualizing how all this comes to be, number one, and then how it works with what we're talking about. That's a sine wave. That could be 30 hertz, or it could be 2 meters long, or it could be 440 that you just saw with the slinky. The long depends on the pitch, which we just talked about, the pitch. C1 is way down at the bottom, a very long one. So there's two other equations that you need to worry about. So write down equation, something equals, let's say C. We already said equals, and then put a line. A line. Now the first equation you need to put up there is 300 on the top of the line. 300. That is the speed of sound. Got that wrong? I don't want to get something wrong. That's the speed of light.
300 light.
So if you want to know the frequency, okay, and the length, this is the equation that you need. This is one of the equations usually are questions on the radio test. Okay, so you would want to know frequency for F. Okay, C would be distance. Now under there put another one. It's more pertinent. Another equation, yeah, more pertinent to what we're doing. And this one, put 1 on the top. Okay, and then put down F equals that.
Yes.
F, yeah, 1 on top. F equals, down at the bottom, put time. Now this one goes with what we're talking about here. Put it in your head if you can. That unit there, we made unit circle of 1 is 1 second. 1 second. Okay, so this equation will tell you the frequency. Okay, so what we're trying to do is, because we're doing this in mathematics and physics, but the instrument's going to do it and you won't even know it unless you learn it, okay? The instrument's going to do this for you. Okay, so if the time in second is 1 second, then that's your equation to find the frequency. So let's say it's 5 seconds. So put frequency is 1/5 equals what?
1/5.
Put 1.0. Make that 1.0. Yeah. 5 into 10 goes 2. So the frequency is going to be 2.0. Okay? So now if you track this so far, what we're up to is the frequency of the cycle. Okay? So let's go through some instruments. Give me the ukulele. Okay, Haley, hold up. Once you know your circle of fifths and tag along circle of fourth, you're going to know most of the instruments that you will have come in contact with. They all are going to follow that pattern. Okay? Now take your guitar. Haley got this guitar for Christmas. So, do another page. Okay, now put the guitar. This is a standard tuning for guitars now. So when I say standard, this is what you're going to learn to start. Once you become a professional, it's going to be a lot more complicated. So you'll have different tuning. Drop D tuning is one of them. They drop the D down. So if they drop the D, it's probably going to become a C. Okay? So write down the strings. The first string is E, B. Now you'll see where the pattern starts coming in. G, D, A, E. 1, 2, 3, 4, 5, 6 strings. Right? So now Roy plays guitar. He has a guitar that's 7 strings.
Oh, that is 12.
So what they can do is
12.
double up those strings, or they
12.
can add a different one, just like they can drop a C down. They can add a string in a chord where there might be a G here and let's say B here or D here. Double strings. They do that on ukulele too. Ukulele's got strings. So. Okay, well, give me the violin. Now if you look at that and you can digest what I've set up to now, there's something a little funny there. The thing that looks funny there is the B. Why is there a B? Just think about that a little bit. Okay, here's a violin. Okay. Violin string, because it's a high soprano instrument, guitar is middle to low. Okay. So let's put put in a guitar E equals, or no equal, make that E 3. No, the last one. That's E3. So this is something you must know if you're going to play guitar, because they cheat a little bit. That other E is the E above middle C, so that's E4. Okay, this is where all this is going to hopefully start to make sense. This is a violin, and it's soprano. Now we're moving way up above that E. Okay. So here, again, we have G is a low string, G, D, A, E. Okay, again, the circle of fifths. Remember the bead, B-E-A-D, backwards. Okay. So, and this one here, this G, this is E5. Okay, G4. So that's where she plays. Serena, who plays the violin. She's playing up, way up, soprano range. Okay, guitar, generally speaking, is down low. So, but it backs up everybody because there usually is soprano, alto there. Now, let's get into electronic music.
This is supposed to go on. For like 1 minute.
Just unroll that a little bit and look at it. This goes back to 1920. These are piano rolls. I had a piano that played these for years. I sold it. When I left Panama, somebody wanted it, they bought it. Now look at it very close. Which on one side you see the words. The rest of it is the melody. So I used to spend hours looking at this. I wanted to play along with it to figure out what notes those were and what's the timing of the note, whole note, so on. So that's music notation done in a different way. Okay. Now, give them back to me. After that, around late 30s, 1940, came the Hammond organ.
Oh, it went off though.
So
Well, it
Haley,
didn't go
stand
off,
up.
but no. It's not gonna go off, I don't think.
Haley, stand up. These here are called drawbars. Now let's draw up there. A equals 440. Okay, that's A4. A5 equals above it. And that's, yeah, A5 equals 880. Yeah, and A3 equals 220. Now, what these are, write down harmonics. Harmonics.
Here?
Harmonics, yeah, right there. Harmonics. Anytime you play an A, you are going to get lots of sine waves, not just one. You'll get an A440, you'll get an A880, but then you might, a C might slip in there. Okay, or B might slip in there. So Hammond, Mr. Hammond, from Midwest Illinois, come out with a Hammond organ. This is a Hammond organ that we sold to Japan, Yamaha. He came up with these drawbars, 0 to 100. So write down, look at them. Look at them. So you know a little bit what you're trying to represent, just lines. Then on each line it goes from 0 to 10.
How many lines?
How many lines are there? Tell her. Tell her how many lines.
How many?
How many of these?
9. Oh, I'm
Yeah,
doing
9. There's only 9 of them.
Okay, write down 0 at the bottom, 10 at the top. Then 1, 2, 3, 4, 5, 6, 7, some kind of number. Just put 5 in.
Oh, I just didn't hear.
Okay? These are drawbars. So what he did is come up with drawbars, and in front of each of these draws, he had a wheel spinning around. That wheel's like a whistle. When you blow a whistle, that little ball goes and it comes up with a pitch. So each of these will have a pitch, and you can change the pitch. Okay. So he found that in physics, there's a certain ones that are important, and we won't go through these, but there's certain harmonics that will be there with a note. And it could be a third, it could be a fourth. We do know that here, A440 and A80 is an eighth, 8 of them. So if you put the harmonics in the middle, then you can start changing the sound. So let's take, down at the bottom, make a big triangle up to the middle one, there, up to the middle top. A line from the bottom. I know this is complicated, but this is what you're supposed to be learning. So if you were a high school musician back when I was in high school, and you wanted to make money on a Friday night, you'd take this organ here. And if you made that there with these drawbars, you would have, let's say, violin sound. If you changed it, brought it down, let's say just slide it over, you would change it to a trumpet sound. And I have all that in a book, so we can teach how to do it if anybody wants to do it, but that's 1940, 1950, and so on. So anyway, that's the old way of doing what we call a sequencer. Okay? Now I'm going to show you the new way. This is an accordion. It's a regular accordion that what we did was hack. So it's hacked now, and this is a leading company in the world now on electronic music, one of them, Roland. They make the majority of the electronic accordions. The ones most professional accordion people play now that electric or electronic are around $8,000. So we didn't want to spend $8,000, so we actually made one. So they actually put out this here and this. A keyboard fits here. This is called a synthesizer. Okay, gets electricity here from USB in. Okay, and now I'm no longer playing an acoustic accordion with sound from reeds. Now I'm playing electronic. So everything we've covered so far now is coming from here. So if any of you are into rock and roll music and all that kind of stuff, this is a synthesizer. You make all these weird sounds. Slide your finger up, whee! It's a wow pedal. On an organ, they call that a wow pedal. I just hit my foot over, it goes, whoa! A siren, basically. So here's to slide it, and so on. So this is the important part, though, because we're still talking sound. This here, write down the envelope under there. Just envelope. So you can see that this is not for beginners. Okay, this is for probably a high school student who's interested in math and physics and MIDI music. Very few of them around in Killeen. Okay, so read that. What does it say? Tell her and write it down.
This is attack. Decay.
Can you read it? Should what? Tell her what to write.
Decay, sustain, and release.
All four of them. Haley? All four of them. There's four of them in the envelope. This is the envelope and sound. Now we take the sound that we've talked about so far and we put it in an envelope. So far we've massaged it in a couple ways based on math, a couple ways based on physics and so on. And now what we're going to do is massage it more. Okay, we've got what? Decay, how it's going to slide off. Attack, how I'm going to attack it. Piano, pound the piano. Pizzicato, legato, nice, smooth, and so on. So you've got 4 ways to take that sound wave and make it into another sound. So now down at the bottom here, if you look on my organ, these keyboards today, the Yamaha, you just push a button and I've got a trumpet. So I don't need a trumpet player anymore. Okay, push the button, I've got a clarinet player. So I don't need a clarinet player anymore. So if I have enough of these, I connect them together and I can have one playing trumpet, one playing clarinet, one playing bass, one playing guitar, and musicians are doing that. In '86 on the Riverwalk in San Antonio, Saturday night, a good musician was down there making money every Saturday night with what I'm telling you. And then when we hired him to play at the university with his band, he starts adding the instruments. So if you're in a MIDI band, you just push a button, the trumpet comes in. Push a button, trumpet goes out. So.
That looping, don't they, now? They have looping machines.
Okay. Let's see, do we cover? Oh, one more thing we wanted to cover. This again is a acoustic accordion, not hacked. We've actually hacked 3 accordions in different ways, okay? And this is what you call a diatonic accordion. This is not a chromatic. This is C roll, G, F. So if you want to play in the key of C, you play here. If you want to play in the key of G, you play here. If you want to play in F, you play here. Got it so far? Okay, turn the page. Now we're going to turn the clock of fifths. Taylor, let's see what you can do. Let her do it. Make a circle.
You can write it more towards the bottom if you need to.
Now we're going to turn this circle of fifths into a clock. Only because it's a little bit easier to use in your head as a clock. So remember we had steps. So step one is a box at the top. A box. Okay. And then the way to remember this is F, C, G. So put F, no, in the box. F, C, G. The mnemonic for that is for the common good. For the common good. Remember that. For the common good. And you'll never let it go wrong. Now put a box down on that side. No.
On
The side.
On the
There.
side.
Yeah, that's
No,
okay.
that.
There's something can go there too.
Right?
Okay, now on one on the other side. Now when you're using this for a mnemonic, the next one is over here, put B-E-A-D. No, start up at the top. B-E-A-D. And that bottom one where you started to do, just put an X there. I told you we're not going to use that. Probably until we get to university level. Then go B-E-A-D up. B-E-A-D. Okay, now above the G put one sharp. One sharp. And above the F put one flat. Now, take your hand. This is a clock, so put that on C. Yeah, okay. So, if you count over, G is 5. 1, 2, 3, 4, 5, if you remember the last one. So, a fifth. This one is a fourth. 1, 2, 3, 4. So if you put your 3 fingers there, you can't go wrong. You know what key, and you know how to transpose it. Put your hand up there. Middle finger on C. Okay, this finger on G, this finger on F. Now turn that all the way over to A. A. Over this A, I'm sorry, the sharp, the violin, over here.
On this side. On this side.
That A. Put your middle finger on A.
On this side.
Middle finger on A.
This A.
It's got to go like so. It's a clock. You're going around the clock. Okay, go back to A. Right. Tonic, dominant, subdominant. Remember what we said those were? Tone 1 is tonic. Why don't you write that down for her? Tone 1 is a tonic. Okay, tone 5 is a dominant. Tone 4 is a subdominant. So that's 1, 5, 4. Now there's another way to do this too. I was going to show you, but I decided it probably would confuse you more. You can do this with what's called a slide rule. You know what a slide rule is? Anybody? You know, when I was in high school and college, we used a slide rule. We didn't have calculators. You had a rule, slide it back and forth. So instead of making a circle, you can make a slide rule and go up and down. When you go up and down, you're changing the pitch, changing the key, up or down. Just like you do with your fingers there. As you go up, everything's going to change. So A is where the violin likes to play, that A up there. Okay? Therefore, that would be your tonic. Okay? Okay, then you have your dominant with your fingers like so, 1, 5, 1, 5. Okay? I don't want to get into, that's, A happens to be 3 sharps, if you remember. You put that up there
1, 2,
last time.
yeah.
Okay. Okay, let's stop there.